Welcome to the Bentley Institute's training course to learn how to perform a modal response spectrum analysis in Staad Pro. A modal response spectrum analysis is a more elaborate type of seismic analysis. Response spectra are plots of maximum response, either acceleration or displacement, of single degree of freedom systems subject to specific excitation. Over the next series of videos, we will show you how to perform a modal response spectrum analysis in Staad Pro, which will include the process to define your dynamic masses and your response spectra load item. We will show you how to specify the maximum number of mode shapes, generate your load combinations, and review the analysis results to ensure that they are in accordance with the requirements of the ASCE 7.
After you create your dynamic masses and also your dynamic loads that you're going to be using in your modal response spectrum analysis, you are now ready to perform the analysis and review the results. Now typically in Staad Pro, the process for doing a modal response spectrum analysis may be an iterative or trial and error analysis, meaning that we will perform our first analysis and then we will check our results to see if they are in compliance with the AISC 7 requirements. Typically, we may have to go back and increase the number of modes that we calculated in our model based on our mass participation results, or we may have to adjust the factors imposed on each of our response spectrum load cases after we review the base shear results for both our equivalent lateral force procedure and also our dynamic analysis. Once we review those processes, it may need to go back, change some parameters, and then reperform the analysis before we review our final results, which may include reviewing some of your mode shapes in the post-processor. Before we perform the dynamic analysis in Staad Pro, we will first enter one more command, which is the cutoff mode shape command. In Staad Pro, you can use this command to instruct the program to extract the specified number of modes during a modal calculation, response spectrum analysis, and time history analysis. We will start with an assumed number of modes to analyze for the sample building structure. Then, after we perform the analysis, we will review the results and the mass participation for the model. If the mass participation is less than 90%, we will increase the number of modes and then reanalyze it to be in compliance with the ASCE 7 section 12.9.1. To specify the cutoff mode shape command, we will go up to the Commands menu bar item, select Miscellaneous, followed by the Cutoff Mode Shape item. In the Cutoff Mode Shape dialog, we will specify an initial number for the maximum number of mode shapes. Then, after the analysis is complete, we will check our mass participation for the model, and then we may have to increase or decrease this number depending upon the results. For our first run, we will enter a maximum number of mode shapes as 20, and then we'll go ahead and click OK. It's also important to Staad to make sure that you save your model before performing an analysis. Next, we'll specify our analysis command. Over in the page control area, we will select the Analysis Print tab, and for this run, we will be performing a traditional analysis in Staad Pro. In the Analysis Print Commands dialog, we will select the options to show the mode shapes in the output file, and then we will go ahead and click the Add button, followed by Close. Once we are ready to perform the analysis, we will save the model, and then select Analyze, Run Analysis in the menu bar. After the analysis is complete, we will be able to review our mass participation and base shear results in the output file. In the output file, we will click on the results bar, and since we selected the mode shapes in the analysis command, we have some additional quick links over in this results bar. We will go ahead and click on the participation factors item to get some information on the participation for each mode of the model. Now we can see in this run that we have not achieved 90% mass participation in the global horizontal z-axis direction. So before we review any more results, We will exit out of the output viewer and then increase the number of modes until we have at least 90% participation in both directions. To exit the output viewer, we will go File, Exit, and then we will reinvoke the cutoff mode shape command. Again, this can be found under the Commands menu, Miscellaneous, followed by Cutoff Mode Shape. This time we'll increase the maximum number of mode shapes to 55, and then we'll click OK, and we can re-perform the analysis. To re-perform the analysis, we will just go back to our Analyze menu and say Run Analysis. After the analysis is complete, again, we will return to the output file and review our new mass participation results. Here, if we scroll down, we can see that we have achieved more than 90% mass participation in each of the horizontal global axis directions. So 55 modes for this particular model seems appropriate. In addition to reviewing our mass participation results in our output file, we should also review our base shear for both our dynamic analysis and also the equivalent lateral force procedure to ensure that those are in compliance with the building code as well. Here within the mass participation table, I can see what the base shear in each direction is. Here is in the positive X direction, and as I scroll through, I can again select participation factors. Scroll down, and here's the base shear in the negative X direction. And also in the positive Z and X direction. If I scroll up in the output file, I also have information, since for this sample model we set up an equivalent lateral force procedure load cases, I also have some information there. Here I can see the base shear in the X direction for the seismic IBC seismic load case, and also in the Z direction. Once I'm done reviewing this information, I will return back to my Staad Pro model and adjust my scale factors on each of my dynamic load cases to ensure it's in compliance with the code. The last step in our modal response spectrum analysis is to review our ASCE 7 requirements in section 12.9.2 and 12.9.4 to ensure that we have incorporated the proper scale factors in Staad Pro. Now in our initial run, we set our scale factors equal to 1.0. So to determine what a more appropriate scale factor will be, we will multiply it by the quantity of I over R, multiply it by 0.85, times the equivalent lateral force procedure base shear divided by the modal response spectrum base shear. If we perform these calculations using our I over R quantity, and for this exercise we will include an importance factor of 1.0 and a response modification factor in the X direction of 8 and in the Z direction of 6. Now we would see that a more appropriate scale factor for our seismic load in our X direction would be 0.023 and also 0.071 in our Z direction. We will now change our dynamic load case and then perform our final version of the analysis. To modify the scale factor for each of our seismic load cases, we will return to the General tab in the Page Control area, followed by the Load and Definition subtab. Here we will expand our load case details section and modify each of our dynamic load cases. To edit a load case after you create it, we would just highlight our dynamic load case, and then we'll go ahead and click on the Edit button. This will bring us right back with all of our response spectrum parameters, and we will need to change our scale factor in our X and Z directions. For our X direction, the scale factor should be 0.023, so we will make that change here, and then we'll go ahead and click on the Change button. And then we will repeat this process for the other dynamic load case, this time in the negative X direction. And we will keep the negative sign, but we'll change the scale factor to 0.023. And we will again repeat this for the z direction. Once you have finished that process, we will go ahead and save our model, and then we're ready to reanalyze. To perform the analysis, we will go up to our menu bar, select Analyze, Run Analysis, and this is our final analysis run. We now know that our mass participation factors and our scale factors are appropriate and in compliance with the ASCE 7 building code. Now at this point, we can continue to review some more results in the output file, or we also have several dynamic results that we're able to see in the graphical user interface through the post-processor. To access the post-processor, we will click on this Go to Post-Processing Mode radio button, and then click Done. In the Results Setup dialog, we will go over and select the Results View Options tab, and we will enable automatic scaling. This will make it a little easier for us to be able to see our results, including our deflection results. And we will go ahead and select our mode shapes along with all these other options as well. One of the first sets of results we're going to review is our member force results. If we go over to our page control area, we can select the Beam tab followed by the Forces sub-tab. Now we can review the member force results for our bending or shear right in our main graphical user interface, and we can select the different options by selecting the different load cases available from our results pull-down menu. Here we are showing our dynamic load in the positive x direction. Now when we had set up our load cases for our response spectrum analysis, we did instruct the program to consider a sign in our results. And we can notice that we do have results in our dynamic load cases issued for positive and negative. Also, since we did perform a dynamic analysis, we do have some dynamic results available. If I go over to the page control area, I can click on the Dynamics tab and the Modes sub-tab. Here I can see the mode shape for each mode in each dynamic load case in the model. To select from the different load cases, I could just use my load case pull-down menu. And to select the different modes in the model, I can use my mode pull-down menu. And I will be allowed to see any mode that I included in the calculation.